catch 'em all.
Good morning to you all and welcome on board the Magic Boat. For those who are new to my channel, my name is Maciek and I live on board this classic motor cruiser behind me. Today I am particularly excited because this is the first episode of the entire new series about how to keep warm, stay dry and be happy on board the boat during the winter season. In this episode we are going to insulate the windows. We will start from the portside windows, then we will move to the bow, and then we will do the starboard side. But we are not going to cut material just yet. Before that, I want to show you the calculation which I have done before selecting material which I'm going to use on these windows. So let's get started. Please come in. Welcome inside. Thank you for coming. As I just mentioned, before we are going to cut material and put inside the cabin, we are going to crunch some numbers. I also going to draw for you few drawings. I hope that this little bit of theory will help you and allow you later on to do the calculation for your boat. As all boats are different and depends on where we are in the world, we have access to different materials. But before crunching numbers and drawing pictures, let's have a coffee and let's eat this nice croissant. Welcome after a coffee break. As you can see, I wasn't only drinking coffee, but I also prepared this little presentation for you so we can understand the physics behind heat loss on the boat. But before we will talk about boats, let's talk about something more familiar to everyone, and let's talk about heat loss on the wall in the building. So let's draw a little drawing. We have an inside of the house, and we have an outside of the house. The temperature inside, let's assume that we want to have 16 degrees centimeters, and temperature outside, let's assume that it's very cold winter. Let's say that it's -20, so that might be Canadian or Polish winter. It's not UK winter, but let's leave it like that. So we have a wall between inside and outside environment. So our wall will be built from bricks. That will be our bricks. Then we will have fiberglass insulation board. And then we will have a fiberglass insulation, slightly thicker. And then we will finish with another fiberglass insulating board. So let's make that maybe all like that, and this like that, and this is this fluffy fiberglass. It's not boat fiberglasses. Let's put some dimensions on our drawing. So our outside wall will be 10 centimeters. Our fiberglass board will be thin, will be 1.2 centimeters. The width of the fiberglass insulation will be 8 centimeters. This board will be 1.2 centimeters. So it's quite thick wall, and I will not go into calculation of this wall, but for this wall, inside temperature of 16 and outside temperature of -20, this wall have a heat loss equal 13.5 watts per square meter. So this is well insulated wall. This is harsh environment. So this example is only to give you a feel for what is the good value for heat loss in normal building. So let's talk about the boats. So on the side of my boat, I have a situation like that. So this is side of my boat. Oh, it's more like that. And then this is my wheelhouse, and I have this one big window. It's nice and curvy. So this is fiberglass. This is glass. And my frame, believe or not, is aluminum frame. Let's draw a frame. And this is aluminum frame. And then I have this. So this is where the holes start. So we are going to insulate this side. So this is port side. We start from the port side. In terms of the materials that I have a glass, aluminum frame and fiberglass. How we can calculate this heat loss? Let's go back to equations. You can see, to calculate heat loss, we have to know inside temperature, and we have to know the outside temperature, and we have to know the sum of all thermal resistance. So coming back to our wall, every of these material have different thermal resistance, and basically we have to sum up all this value, and this will be sum of the thermal resistance in the system. And actually this is not true, because we have two kinds of thermal resistance. One, convection, and second is conduction. So this is all caused by the conduction, because heat transfer through that wall. And the convective environment, it's the inside of the boat and outside of the boat. We all understand what is inside temperature, outside. So how we can calculate the thermal resistance? Thermal resistance is calculated by dividing the width or thickness of insulation material by his thermal conductivity. For my boat, my materials are glass, aluminum and fiberglass. I have a table of thermal conductivities for different materials. The best insulator on my boat is fiberglass. And then we have a glass, and then we have a plywood, and then we have aluminum. And aluminum we shouldn't call insulator, because aluminum is conductor, but that didn't stop the designers and the builders to make windows frame from aluminum. So this is very bad. This is very good thermal conductivity, but the bigger conductivity we have, the smaller thermal resistance of the material is. And the thicker material we will have, then bigger thermal resistance will be. So just to kind of wrap it up, TR is thermal resistance. This is the thickness of the insulation material, and alpha is thermal conductivity of that material. So let's start our journey towards understanding the heat loss on the boat from calculating the thermal resistance for all material on the boat. We have a fiberglass, glass, plywood and aluminum. And I make this table so the best insulator, currently the best insulator I should say, is on the top, and then we're going down, 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 and this is the weakest insulator, is actually conductor. So let's start from fiberglass. We need to know two things. We need to know thickness of the material, in this case fiberglass, and thermal conductivity. So I have 5 millimeters fiberglass wall, and we need to convert that into meters. So in meters, so this is 5 millimeters in meters. Then we have this handy table. So thermal resistance for fiberglass, we call TRF, will be equal to 0.005 divided by 0. N is equal 0.11. The next insulator is a glass, and again I have 5 millimeter glass. That's convert to the same value. Thermal conductivity for glass is bigger, so we will expect value to be smaller. Yes, let's test that. TR G for glass is equal, and that's equal 0.00. So the fiberglass have bigger thermal resistance than the glass, because glass have better thermal conductivity. So putting the aluminum frame with the thermal conductivity of 237, it is interesting design decision. But let's not worry about that. Let's calculate the thermal resistance for aluminum to see the difference. This time the aluminum frame, it's not 5 mil, but it is 30 mil. So that's converted to 0.03 meter. So thermal resistance for aluminum is equal to 0.0001. So you see, even that this is the thickest insulator, this is the weakest insulator because it has almost no thermal resistance. So now we know how to calculate the thermal resistance of the different materials which have different thickness. So let's begin analyze the problem of heat loss on port side.